Hello, today we're going to be talking about how gas moves throughout the body. So first we have to know what gases we're looking at. So we're going to be looking at carbon dioxide and oxygen. So we have to find out what parts of the blood they're in. Oxygen is in red blood cells and CO2 is in the plasma, but it's in a different form. So let's look at that right now. So how carbon dioxide is moved in the blood. So first, it starts out in the red blood cells where CO2 is converted into bicarbonate, which is then moved to the plasma, and that's where it moves. So what things in the red blood cells help move oxygen? That would be hemoglobin. Hemoglobin picks up oxygen and drops oxygen off at the sites where it's needed. And it does this through a mechanism called cooperativity. So what is cooperativity? I like to think of cooperativity as pushing a snowball down a hill. It starts out small, it's hard to push at first, and then as it gets bigger, picks up speed until it reaches the bottom, and it's moving the fastest at the bottom. So how does this relate to hemoglobin and oxygen? So whenever the first oxygen is hard to bind, that's how you see on this curve here, it's hard to bind the first oxygen. And as you bind the next one, and the next one, and the next one, it makes it easier. So the first one's hard to bind, the second one's easier, third one's easier, fourth one's easier, until you've reached the maximum number of oxygens, all in the hemoglobin, which is 4, which you can see in these 4 binding sites. This is the more complicated part, what actually makes this stuff happen, and where. So first, there's 2 sites of gas exchange. There's first the alveoli and the pulmonary capillaries, which are just little small veins. Capillaries, small veins again, at the tissues. So first, we're going to look at the air we're breathing in. So it's oxygen, nitrogen, and CO2. We're not going to look at nitrogen, so we just don't need to know about that right now. So we breathe it in. The numbers aren't entirely important here. But you have to know that the blood that is coming in and that is going to be the gases that are going to be exchanged with the alveoli at the pulmonary capillaries is deoxygenated, which means it doesn't have not a lot of oxygen in it. So when this blood comes by the alveoli, this oxygen is going to flow into the blood. The CO2 is going to flow into the alveoli. So the oxygen comes in, we have a higher number of oxygen than we did before. So this blood's going to be, it's going to be called oxidized. It's going to come into the left side of the heart, which is then going to be pumped into arteries in the body. It's going to go until it gets to the capillaries, where the oxygen needs to be dropped off in the tissues, so that a lot of processes, how you contract your muscles, all of the sorts, oxygen is important. You knew that? Oxygen is going to be dumped off at the tissues. CO2 is going to be picked up at the tissues. That's why you see increase in CO2 after the tissues, decrease in oxygen. This blood is now deoxygenated. It's going to flow back to the right side of the heart, and then right back into the same system. And that's how gas moves throughout the body.